In nature, atoms are found bonded to other atoms. With the exception of the noble gases, almost all the other elements on the periodic table, their atoms are found in nature bonded to other atoms. There are different types of chemical bonds, or there are different types of chemical bonding, but in this video, I'm just going to focus on the covalent bond. I'm going to give you the definition of the bond, the kind of elements that are involved in covalent bonding, and I'm going to give an illustration of covalent bonding. Now, let us start with the definition. Depending on your syllabus, a chemical bond can be defined as a bond that involves the sharing of electron pairs between atoms. So there is an interatomic bond. So two or more atoms are involved in chemical bonding, and these atoms will be sharing electron pairs. It is also important to point out that chemical bonding in the form of covalent bonding involves non-metallic elements. There are a few exceptions. Where we see or we encounter metals forming covalent bonds, but that is just a few exceptions. In the main, covalent bonding involves non-metallic elements. This is a very important aspect if you are going to identify what we call covalent compounds. If you look at a compound in the chemical formula of a compound, and you see that the elements involved are only non-metallic or non-metals, the kind of bonding there is almost always covalent bonding. There are very important things to point out in the definition. One, there is the sharing of electrons, and these electrons are not just shared singly. These are electron pairs that are being shared. So whenever you give your definition of a covalent bond, don't miss the sharing of electron pairs. This is a very important aspect. It is also quite advisable to include that this involves non-metallic elements. Very, very important. So this is how we define covalent bonding. Now let us illustrate, or let us show how this covalent bonding occurs. I'm going to use these two examples: water and carbon tetrachloride, or tetrachloromethane as it is called. So we have H2O, which is the water molecule. The elements involved in water are hydrogen and oxygen. Both of them are nonmetals, so we expect here to have covalent bonding. I'm going to illustrate how this occurs. Let us draw the Lewis diagrams of each of the atoms involved. I'm going to start with the Lewis diagram of oxygen. So this is O, representing oxygen. When you're drawing a Lewis diagram, you draw the symbol of the element in the middle, and then you surround it by the valence electrons only. The valence electrons, I'm going to use green to indicate the number of valence electrons. If you have forgotten how you know the number of valence electrons, you just have to go to your periodic table. The group number tells you the number of valence electrons. Oxygen is in group 6, so it has 6 valence electrons. So these are the valence electrons. We have them like this. So we got 6 valence electrons in oxygen. This is the Lewis diagram of oxygen. It's fine. Then I'm going to draw the Lewis diagram of hydrogen. And we have 2 hydrogens here. So this is hydrogen. It has 1 electron. I'm going to use a dot to represent the electron. Hydrogen. It is in group 1, by the way. It has got 1 valence electron. It also happens to just have one electron. It's hydrogen. I'm going to use a dot. So the dot is representing the electron in hydrogen. But we have 2 hydrogen atoms here. Another hydrogen atom is here. it also got 1 valence electron, so I just put the 1 here. Now these are the Lewis diagrams of hydrogen and oxygen. We know that when we are doing chemical reaction, atoms bond because they want to achieve the electronic configuration of the closest noble gas. For hydrogen, the closest noble gas for hydrogen is helium. Let me just illustrate helium quickly. So this is helium. This is the noble gas closest to hydrogen. It has 2 valence electrons. It is 2 valence electrons. Helium is 2 valence electrons. Let me just put them together. But hydrogen has got 1, so it needs another electron to be like helium, to have the electronic configuration of helium. It needs 1 more electron, hydrogen. Then if we look at oxygen, it has got 6 valence electrons. The closest noble gas to oxygen is neon, which has got 8 valence electrons. So oxygen needs 2 electrons. So oxygen requires 2. So oxygen needs 2 more. Hydrogen needs 1 more. So this needs 1 more. Now, so what do they do to achieve this? For oxygen, it either gains the 2 electrons and form a negative ion. It can do that. The same applies to hydrogen. It can gain an electron and form a negative ion. But when we are forming ions, this is not covalent bonding. It is now another type of bonding, which is called ionic bonding. We're going to discuss that in another video. But in our case, this is achieved by sharing the electrons. So what happens here is the hydrogen comes here with 1 of this electron that it has. It shares with 1 electron here of oxygen. Then the other hydrogen atoms comes here also, and they share. So in the end, we have this. We have a hydrogen atom here, H here, another H there. Now I'm going to draw these as dots. So see the dot here, the dot here. This is now H2O. This is now water. So what we have here, let me circle this whole diagram here. That is the Lewis diagram of the water molecule. And we are illustrating this covalent bonding. I just want to point out something about this bonding. The oxygen, which is the atom here forming most of or the largest number of bonds, it is forming 2 bonds, by the way. It is called the central atom. So oxygen here is our central atom. Oxygen is our central atom, and the hydrogen obviously are peripheral. Oxygen is the central atom. It's very important for you to know the central atom. So oxygen here is the central atom. In this molecule, it's called the central atom. These 2 electrons here and there, these ones, we call those ones a bonding pair. So these are the bonding pairs. Bonding pairs. So the shared pair of electrons is called a bonding pair. The other electrons that are not shared, like these electrons here, we call them lone pairs. So these are lone pairs. These are lone pairs. So around oxygen, around the central atom now, if you look at the central atom, which is oxygen, around it, we now have 8 electrons, the octet, this very important octet that the noble gases have. We now have it. If we look at hydrogen, it now has got a duet. It has got 2 electrons. It is fine because that is the maximum that it can be. It can just be like helium close to it. So hydrogen is fine also. Everyone is fine. Everyone achieves stability by just sharing. Remember, we say sharing is caring. So this is an amazing example of sharing being caring, because it brings stability to both oxygen and hydrogen. This is how covalent bonding occurs in water. And this is why we write it as H2O. We have two hydrogen atoms bonded or covalently bonded to one oxygen atom. Now, let us illustrate the same on carbon tetrachloride, or tetrachloromethane as it is called. We have in the middle, obviously we're going to have carbon in the middle. If you want to know why we take carbon, carbon is the central atom. It is the central atom because it is the atom that can form the most bonds. Okay, it can form 4 bonds, whereas chlorine can only form 1 bond. So carbon becomes the central atom. So I'm going to write carbon here in the middle. Then it is in group 4, so it got 4 valence electrons. So this is 1, 2, 3, 4 valence electrons for carbon. Now, chlorine is in group 7. I'm just going to draw a chlorine atom here. So we've got Cl. It is in group 7, so it has got 7 valence electrons. Both of these atoms have got a problem. Carbon is having 4. It wants to have 8 electrons in the valence shell, but it has 4. Chlorine itself is a problem again. It has got 7 valence electrons. It wants to have 8. How do they achieve this? They share. The single atoms are shared to form a bonding pair. Now, so we're going to have all these chlorines coming here with their single atoms and sharing with one of the electrons from carbon. So now I'm going to draw here. So we're going to have Cl here, another Cl here, another Cl here, another Cl here. I'm going to use dots for the electrons of chlorine. So the shared electron here, then the others remain, and they are lone pairs. So this is shared, and we've got the lone pairs. We have a sharing here, sharing there, and then lone pairs. All right. So this is the bonding in carbon tetrachloride. Everyone now is happy. Look at chlorine. Around chlorine, we now have got 8 valence electrons. Around carbon, which is our central atom, we also have got 8 valence electrons. Now we have achieved the octet. Each of these atoms has achieved an octet, which brings stability. So this is how the bonding occurs. So these electrons here, we call them, these are the bonding pairs. These are bonding pairs, which means around carbon now we have 4 bonding pairs. We have 4 bonding pairs, but if we come to this chlorine atom, it has got 1 bonding pair around it and 3 lone pairs. The others are called lone pairs. This is it. This is covalent bonding. This is how it happens. It involves the sharing of electrons between 2 atoms, and the shared pair of electrons is called a bonding pair. And this sharing of electrons occurs because each of the atoms involved wants to achieve an octet, or it wants to achieve the electronic configuration of the noble gases. If you have any questions or any comments, just write in the comment section below. Otherwise, I thank you for watching the video. Give it a thumbs up, subscribe to the channel, and share with your friends.